Hello, everyone. Hope everyone is having a good day. And today I'm going to do a chemical reaction for you, a classic one. So inside of my test tube here, I have water, and I'm going to put some baking soda into my water. A couple of scoops of baking soda. Not very precise today. And I'm also going to put a little soap in. Don't actually need the soap for this, but I think it makes it more exciting. Now, I'll try to do this without making too much of a mess. Let it settle down a little bit. On. It's all sudsy at the top. Ay, 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 ay. Suds. Okay. Now that it has settled a little bit, I'm gonna add some vinegar to it. Ugh. Huh. Right? It bubbles. Super cool, right? Look at all that bubbling. Bubbles! So baking soda and vinegar, as you know, create gas. The reason I add soap is because it makes it more bubbly. Okay, we're gonna pause there for me to clean up. I shall be right back. Okay, I am back. And so the reason for that is because we're starting our new unit, and our new unit, of course, is chemical reactions. Talking all about chemical reactions. Um, so let's get to it. And really, the big things that we're going to learn today about chemical reactions is just some of the common language of chemical reactions in chemistry. Of course, I have a QR code in case you need your reference table. So, an equation in math. We know that an equation must have an equality. And yes, I use the word equation and equality in the same sentence, so that doesn't help us too much. But if I said that we have 6 plus 7, this is not an equation. If we have 5 plus 2 equaling to 6 plus 1, this is an equation, right? So for something to be an equation, it must have our equal sign. That's what an equation is. A chemical equation is a math equation, just with chemicals. So we're going to remind ourselves that, let's say we have a couple of elements. And remember that elements can be either big letter, little letter, or just A, B, X, Y. And then we have some compounds. They could be or, so A little xb, AB, XY, those are our compounds, right? So For any chemical equation, for an equation, it might look like this. Here's our equation, and we could have something like AB plus XY equals. But in chemistry, we don't use an equal sign, we use the arrow sign. I'm going to actually make that arrow sign a little bit bigger. Okay, and that might equal, let's do ABX plus Y. And then we have some very special names. Anything on the left side of a chemical equation, we call the reactants. Anything on the right side of a chemical equation, we call, that wasn't a good squiggle, the products. And we have a very special term for our equal sign or arrow. We call that's our yield sign. So the way we would read this is AB plus XY yields ABX plus Y. And that's a general equation. Let's look at a more specific equation, the equation to make water. If you mix hydrogen gas. Oh, wait, we never went over that. Let's go over what that means before we do that. See how we did a little subscript there? That's because in chemical equations, we can show the state of matter. And we do this with subscript letters. Okay. And our letters are S, that's a lowercase script, L, G, all lowercase, and A, Q. It's also common that sometimes we put them in brackets, curly brackets as we call them. And obviously, remember S is for solid, L is for liquid, G is for gas, and AQ is for aqueous, aka dissolved in water. So let's go back to the equation to make water. We would have H2 gas plus O2 gas yielding H2O gas. Now, there's something that many of you are probably pointing out and yelling at the screen that we have to remember. There's something called the law of conservation of mass. Hopefully you remember that, which tells us that matter can't be created nor destroyed. Only changed. And why am I bringing this up? Well, in chemistry, all balanced equations must fulfill the law of conservation of mass. This one we can tell doesn't. How can we tell that? Well, let's take a closer look at it. I'm going to recopy it down. You can too if you want. So we could say that if these are combining in the units of moles, in the in the reactants, there is 1 mole of H2 and 1 mole of O2. In the products, there is 1 mole of H2, and this is tricky, and 1/2 a mole of O2, or 1 mole of O atoms. So notice how 1 mole of O2, 1/2 a mole, we broke the law of conservation of mass. So what can we do? Well, we can just fix it because we know in real life this isn't the appropriate actual real equation. We can fix this equation so it shows off what's going in real life. And that's called balancing an equation. When we balance an equation, we make it so it fits the law of conservation of mass. And that's just, that's something we have to do. And to do that, we just change the numbers. But let's say we take H2O. We can't just add a 2. Because if I just take this 2 and I put that 2 there, right? The problem is that this is not water. I want an equation, my original equation, to always make the same substances. If you change a subscript, it changes the substance. And balancing should never change the substances. Balancing should only change the amount of substance, not the chemical formulas. So how do we do that? How do we change it? Well, instead of adding subscripts, we add coefficients. And you can add any coefficient you want, but remember, we want the smallest whole number ratio of coefficients. Okay, so we can add anything we want as long as it's a whole number. What can we add? Well, we see that there are 2 O's on the left, 2 O's in the reactants, 1 O in the products, so I could throw a 2. The problem is this 2 here applies to this whole H2O. So now I have 2 O's, but I have 4 H's. What do? Well, I just throw a 2 here. So the correct way of writing out this chemical equation would be 2H2 gas plus O2 gas yields 2H2O gas, right? Not super hard. let's look at another equation. Let's do Na plus BeO yields Na2O plus Be. Once again, we have to double check. So here's what I'm going to do. I'm going to count things out. 1 O in the reactants, 1 O in the products. Yay. 1 Be in the reactants, 1 Be in the products. Yay. 2 Na in the reactants, 2 Na in the products. Yay. So how do I balance this? Let's put a 2 in there, right? And that is how you balance equations. And you can always double check if you balanced your equations. If you go back and you just read the old equations and just see how much you get, right? And it's just kind of this big game of just figuring things out. Now, there are a couple of little tricks. Let's look at one specific little trick I can tell you, and this has to do with polyatomic ions. CaNO3 2 plus AlPO4 yields Ca3 PO4 2 plus AlNO3. Now, at first glance, if you were following what I did before, you'd start counting things out and you'd be like, well, 1 Ca, 3 Cas. There are 2 Ns, 3 Ns. But then when you look at the O's, there are 6 there are 4 there are 8 there are 9 there. It gets super complicated because if, let's say, I were to try and balance it out, so 6 and 4 is 10, that's 8 and 9 is 19, right? What if I wanted to make more over here? Well, if I were to, I don't know, let's say double this, the problem is that I double that, but I haven't changed this amount of O's over here. And so I can't really tell which O's I'm supposed to change to balance it out. It's more complicated. However, there's a trick. Just like we did in the crisscross method, we can treat polyatomic ions as a single unit. And that's going to make your life so much easier. What do I mean by that? Well, let's take a look here. That we have 2 NO3s here. We have 3 NO3s there. We have 1 PO4 there. We have 2 PO4s there. So I'm going to assume that I need to double my PO4s. Let's say I might need 2 of them. Look at that. Now my phosphorus cancels out Al. Uh-oh. I have to add more Al though, right? So let's put a 2 there. But I noticed that now I have, what do I have? I have 6 NO3s. I only have 2 NO3s there. So I need to triple that amount. Okay, and let me just double check to see how I'm doing. 3 CAs, 3 CAs. We have 6 NO3s, 6 NO3s. Good. 2 ALs, 2 ALs, good. 2 PO4s, 2 PO4s. Look at that. Because I treated these polyatomic ions as a single thing, it made this so much easier. Okay, so that's my hint to you. Balancing just takes practice, practice, practice. Okay, can't wait to see everyone in class. Have a good rest of your night. Bye.